Acceleration is a change in velocity. Velocity is speed and direction. So, in order for velocity to change, speed must change, direction must change, or both of them could change. There's two types of acceleration. Positive acceleration, which means speeding up, or negative acceleration, which means slowing down. A car is stopped at a stop sign. What is its speed? Well, if it's stopped, then it isn't moving anywhere, so it's going 0 meters every second. So its speed would be 0 meters per second. The reason we're asking that question is because many acceleration problems start with a car or a person or an object that isn't moving. So its initial speed or its beginning speed is 0. If we take that car that isn't moving and we say that it accelerates at a rate of 3 meters per second, or 3 meters per second squared, then we can figure out how fast it's moving as time goes on. If it's going 0 meters per second right now, after 1 second, it will be going 3 meters per second. The acceleration rate tells us that every second the speed increases by 3 meters per second. So then after 2 seconds, the speed has increased by another 3 meters per second. So now the speed is 6 meters per second. Think about if the speed were to increase by another 3 meters per second, what the speed would be next. You should have said 9 meters per second. Every second the speed would keep increasing by 3 meters per second, because that is the rate of the acceleration given above. For the next problem, we're thinking of an airplane that's traveling at 1,000 miles per hour. That is its starting speed. It is accelerating at a rate of 100 miles per hour squared. This means that its speed is increasing 100 miles per hour for every hour that passes. So if its initial speed was 1,000 miles an hour, what was its speed after 1 hour? It should be 1,100 miles per hour. You think about the initial speed, 1,000 miles per hour, and you add the acceleration rate for an hour, which is 100 miles per hour. After 2 hours, we would have to add another 100 miles per hour. So now the speed would be 1,200 miles per hour. Think about what the next answer should be. After 3 hours, we will have gone another 100 miles per hour faster, so the speed would now be 1,300 miles per hour. In the next problem, Alicia is walking at a speed of 0.25 meters per second with an acceleration of 0.25 meters per second squared. So if she starts out as 0.25 meters, and then she's walked for 1 second, she will have increased her speed by 0.25. When we add those together on the calculator, we end up with 0.5 meters per second. Every second her speed will continue to increase by 0.25, since that is the acceleration rate we are given. So on the calculator, for 2 seconds, I could add another 0.25. Can add another 0.25, and I end up with 0.75 being her speed. In order to find her third speed after 3 seconds, we again have to add the acceleration rate, 0.25, to her current speed, which is 0.75. At this point, she is going 1 meters per second. You now need to write the equation for finding acceleration here. What we do to figure out acceleration is we find the final speed of the object minus the initial speed, or the starting speed. And we have to divide that by time, the time that it takes to get up to that final speed. So please copy that equation down. You can also copy it down in a different format. It means the same thing, but you could write it down this way as well. Final speed minus initial speed divided by time. You just have to make sure you finish what's in the parentheses before you divide. Let's try using this in a problem. When Shrek began running, he ran at a speed of 30 meters per minute. But by the time he got to the castle 10 minutes later, he was running at a speed of 100 meters per minute. What was his acceleration? In order to find the solution to that problem, we need to plug in the 3 numbers here. We need to put in the final speed, the initial speed, and the time. His final speed is the speed that he ended at. So if you look back at the problem, try to find the ending speed. The ending speed was 100 meters per minute. The initial speed, or the starting speed, is also in the problem. Look back to find it. You should have found that 30 meters per minute was his starting speed. Now we need to look to see how much time it took for him to speed up, and we see that that was 10 minutes. We have to do what's in the parentheses first, according to order of operations that you've learned in math. So we do 100 minus 30. If you need to use a calculator, you can go ahead. And we end up with 70 meters per minute. We still have 10 minutes over here. That hasn't changed. We haven't used it yet. But now that we've done what's in the parentheses, we can divide by 10 to get our answer. When you divide 70 by 10, you should end up with 7 meters per minute squared. That means that every minute, Shrek ran 7 meters per minute faster than he did the minute before. Now we'll look at problem 8. When Marlin started swimming after the boat that carried Nemo, he was swimming at a speed of 100 centimeters per second. After 5 seconds, he lost sight of the boat, and he was swimming at a speed of 50 centimeters per second. What was his acceleration? We are still using the same formula here. Final speed minus initial speed, or starting speed, divided by time. So you need to look back at the problem and decide, what was his final speed? You should have chosen 50 centimeters per second. Now we need to subtract his initial speed, or his starting speed. Did you choose 100 centimeters per second? Once that's filled out, now we just have to divide the time it took. Looking back at the problem, we can see that it was 5 seconds. Once that's plugged in, you just have to follow through with the math. Do the subtraction in the parentheses first. Be careful to make sure that you do 50 minus 100 instead of the other way around. Since we have a smaller number first, we end up with a negative number, negative 50. When I look at the problem, that makes sense because he started out going faster and he ended up going slower. So we had a negative acceleration, meaning that he slowed down. We still have the 5 seconds in place. So now we just need to do the division. Negative 50 divided by 5 is negative 10. So our final speed, our acceleration is negative 10 centimeters per second squared. Every second that he swam, he had a negative acceleration of negative 10. So we got 10 centimeters per second slower with each second that passed by. Problem 9. When Homer Simpson started out on his walk, he was walking at 30 meters per minute. After 5 minutes of this pace, he was so tired that he had slowed down to 25 meters per minute. What was his acceleration? First, think to yourself, do you expect a positive answer or a negative answer? Since he was slowing down, we would expect a negative answer. It's always good to do a little bit of predicting before you start calculating, just so that you know if your answer makes sense. In order to plug in this equation, the final speed minus initial speed divided by time, we need to look at the speeds first. His final speed was 25 meters per minute. That means that his initial speed must have been 30 meters per minute. Now find the time. 5 minutes. And then we could start calculating. 25 minus 30 is where we end up with our negative answer. Negative 5. And then the 5 minutes just is rewritten for this step of the problem. When you divide negative 5 divided by 5, you should end up with negative 1 meter per minute squared. Number 10. When Tom started chasing Jerry, he was running at 60 meters per minute. After 10 minutes, he had accelerated to 80 meters per minute. What was his rate of acceleration? First, you need to start by looking at his speed. His final speed was 80 meters per minute. His initial or starting speed was 60 meters per minute. Then you plug in the time of 10 minutes and you do your math. 80 meters per minute minus 60 meters per minute gives you 20 divided by 10. When you divide that, you should end up with 2 meters per minute squared. For question 11, you're not given the guides. You're just given blank lines, so you need to write in the steps. Wile E. Coyote's rocket started off at a speed of 500 meters per second, and 5 seconds later, it was going 1,000 meters per second and gaining on the Roadrunner. What was the acceleration of the rocket? Think about what you need to write first. We need his final speed 1,000 meters per second minus the initial speed, 500 meters per second, divided by the time, which was 5 seconds. In order to solve this, I do the parentheses first. 1,000 minus 500. When you do that, you should end up with 500 meters per second, and that's still divided by 5 seconds. When I divide 500 divided by 5, I should end up with 100, and my units are meters per second squared. Meters per second per second.